Thanks everyone for joining us for another one of our Tech Showcase webinars. I've got Joe Bauer from Price Systems here. He's going to talk to us about the TrueFindings service through Price. On your GoToWebinar app, there's a box for questions. So if you have a question, please write it in the box, and we'll be going through all the questions at the end. So with that, I'm going to pass it off to Joe.
All right, thank you. Welcome to our webinar today on data-driven estimating with TrueFindings, hosted by ICA and delivered by Price Systems. Today we'll start with just a bit of background info on myself, as well as how to contact Price Systems if you have any questions after the webinar regarding any of our products or services. We'll discuss the Estimation Systems Integration Framework, or ESI. The ESI is essentially the way we do business at Price, how we support our customers through services, support, and tools. Next, we'll get into the fun part of the webinar where we deliver a live demonstration of TrueFindings, from formatting and importing data to analyzing the data and driving the analysis into our estimates in TruePlanning. And of course, we'll save time for questions at the end. As mentioned earlier, my name is Joe Bauer. I'm the primary solutions consultant for our Air Force users. I've been with Price for about 3 years now, and before that I was active duty Air Force working as a cost estimator for a major acquisition program at Wright-Patterson Air Force Base in Ohio. I'm still based out of Dayton, Ohio. In fact, our satellite office here in Dayton is literally 2 minutes away from all the major program offices at Wright-Pat. I'm a graduate of the AFIT Cost Analysis program and am certified through ICA as a cost estimator analyst. So let me tell you how to contact Price Systems should you ever have any questions about any of our services or tools. The technical support and the other contact info you see here is for our main headquarters in Mount Laurel, New Jersey. Also, if you'd like to contact me directly in the Dayton office, my work phone and email are shown here at the bottom, and I will show that again towards the end. So let's talk about the Estimation Systems Integration Framework, or ESI. As I mentioned earlier, this is how we support our users throughout the estimating process. And you'll notice that our support mimics the cyclical nature of cost estimating, from data capture, normalization, analysis, all the way through modeling, execution, and that all-important step of capturing those actuals back into our pool so our future estimates will be more accurate. Today we're going to focus on one subset of the ESI framework, namely Step 3, where we're going to use TrueFindings to analyze some data in order to drive our estimates with our relevant, accurate historical data. So we'll jump out of the slides now and we'll move into the live demo of TrueFindings. First, I would like to take a look at a publicly available data set on the internet, which we're actually going to use during this demonstration. And we'll talk about taking this data set straight off the web and importing it into TrueFindings and all the work that's involved there. So as you can see, I pulled up a website containing technical specifications of military turbojet and turbofan aircraft engines. This particular data set contains over 1,000 rows for various aircraft engines, manufacturers, models, along with their technical specifications, such as thrust, weight, fuel consumption, etc. So we'll talk about how easy it is to take a data set such as this and import it into TrueFindings. And it can be a large, incomplete data set, and with just a little bit of formatting, we'll have no problem pushing it into TrueFindings for analysis. So what I'm going to do is just copy a section of this data, not the whole thing, and talk about literally copying it and pasting it into Excel, just to give you some idea of what you need to do to any existing data set in order to utilize it in TrueFindings. I also have a fully formatted data set with all the rows of data that we'll actually use in our demo, and formatting that entire data set that you saw on the website into a usable Excel sheet only took me about 10 minutes, and we'll cover some of the rules that we have to abide by right now. There's three main requirements. First, this happened to paste in here one row over than what I need. Okay, here we go. So the very first rule that we need to talk about is column A. Very simple rule. We need to make sure column A is titled name. And each one of these rows of data in our data set will have some name associated with it. And it could be anything, model 1, model 2, it doesn't matter. If I were using this data set in a true problem or analysis, I might even take the model number itself and copy it over here as the name. So that's rule 1, very simple, straightforward. Column A has to be titled name. The second rule, just as simple. The tab at the bottom has to be titled cost objects. And you can have a spreadsheet or a workbook with as many tabs as you want, containing other data, formulas, charts, it doesn't matter. The point here is that when we import this into TrueFindings, TrueFindings is going to seek out that tab and only that tab that is titled cost objects. All right. So our third rule, you'll notice that when we pasted this information into our spreadsheet, we do see that we had some column headings sort of spill over into other rows, right? Here we have thrust, but it's dry thrust. Here we have thrust, but it's wet thrust. If you don't know the difference between dry thrust and wet thrust when you're talking about aircraft engines, dry thrust is essentially that thrust available at full military or cruising power, whereas wet thrust is thrust available at afterburner. But we need to collapse all of this information up into such that our column headings are all contained in one row. So let me do an example of that real quick, just to show you as simple as manipulating the data from the website, and we'll just take these other rows and delete them. Now what we have to do is let TrueFindings know, we have to tell TrueFindings some way of what type of data are contained in these columns. And just by looking at the spreadsheet here, you see that some of these columns contain numerical data, right? And some of these columns contain text. We need to let TrueFindings know what's in that particular column, because it really tells TrueFindings what it can or cannot do with that information. And it's a very simple process here where we just annotate whether there is a number. This column is full of numbers by using parentheses and typing in number. Or in the case of manufacturer, we'll use an example where we just say that the data in this column, it's text. Okay? And we end up doing that for all of our columns here, just annotating what type of data are in those columns. Now, when we talk about normalizing our data set, we go through the same processes in Excel that you likely do in your program office. Changing all of our weights to pounds or kilograms, changing all of our currencies to maybe a US dollar in a particular base year. You can certainly work through that in Excel as you do now, or there are other more complex ways to annotate what that information is in that column. What I'll do is tell you that capability is there, and I'll show you an example of how to identify that information once we import the data into TrueFindings, but we can certainly do that normalization as we import the data set into TrueFindings as well. So this is sort of the work in progress version, and let me pull up the fully formatted data set that I use. This is literally a copy and paste of the information off of that website that you saw, and you see all the three rules abided by here. Column A is titled name. The tab at the bottom is titled cost objects, and I've identified what's in each of these columns, whether it's a number, a text, or even a date. So as I mentioned earlier, taking this information off the internet and developing a fully usable spreadsheet was literally no more than 10 minutes. And it's a very quick process to take a data set that you currently have. And this really points towards not just data analysis capabilities of TrueFindings, but here we're getting really into the data management, because this is giving us a concise structure in order to manage the data sets we have. And this is very much a living, breathing data set. We can continually add columns or rows of information, hopefully at some point fill in all of these blanks once we chase down the information, and we can continually update that and improve our analysis in TrueFindings. So we've taken a look at how to format the data in Excel, but let's get to the fun part where we're going to actually drive into TrueFindings, pull up this data set, and then start looking at the analysis that we can perform. What I want to show you very quickly is an example of a TruePlanning project here. And here we have an example of an aircraft estimate, and we have an engine that we're trying to get a better understanding of the weight of that engine for. And you see we might have some type of early subject matter expert or guesstimate of what the weight should be, but let's go out and harness some data that exists in our program, perform some analysis on it, and let's drive that analysis into our estimate so we can better validate and defend what our inputs are. And that's where we're going today. So I'll open up TrueFindings. And you should see this opening up on your screen now. And this is essentially the blank slate, the starting point of TrueFindings. And there are many boxes and features and tabs and so forth here. Don't worry, we'll walk through each of these as I work through the analysis in the next 35 minutes or so, 40 minutes or so. First, let's import a data set so we have something to analyze. Now go to File, Import. Now I'll simply grab that Excel spreadsheet that you saw just a moment ago. And again, this is straight off of the website that I showed you. I did delete a few columns that weren't really pertinent to my demonstration today, but otherwise this was picked straight off of the web. Now once that imports, you'll notice that you have over 1,000 rows of data. In fact, we have 1,076 rows here. And all of the column headings that you had in the Excel spreadsheet are column headings in the data set. That's great. But these column headings also become filterable, searchable criteria over in the left-hand side here. And some of the things that we can do with that are, let's imagine now that we want to maybe filter this data set down to only a few engine manufacturers. We'll pretend that we're only interested in engines from GE, Pratt & Whitney, and maybe Rolls-Royce. And you notice in this manufacturer column we have many other manufacturers listed there. But let's go over to our search box, and when we open this manufacturer up, we can now narrow down on those specific manufacturers, GE, Pratt & Whitney, Rolls-Royce. And once I click the magnifying glass here, you'll see that I've invoked these filters up here at the top, and the data set has now been narrowed down to 429 rows of data. Haven't deleted any, I've simply filtered those other rows of information out. If we ever needed to delete any of those filters, we can simply click the X next to those data points, and you can see that the number of data points will increase or decrease rather as we narrow it down even further. Now we can also filter on numerical data too by providing a range or an upper or lower cap. For example, if I only wanted to filter in or filter or search on engines with a thrust between maybe 9,000 and 13,000 pounds, I can enter those values here in the lower left, and again when I hit the magnifying glass, this filter shows up, and now I'm only looking at those data points which are relevant to my particular situation. Again, anytime you want to include or exclude specific data, you can do that through the search section over on the left-hand side. I'll close that out. So we talked about normalizing data in Excel, just as we likely do now. We also have the opportunity to normalize data upon importing or even after importing the data set into TrueFindings. So I'll demonstrate the latter now. I'll go to the end of the columns here, and you see dry weight. Right now, TrueFindings considers it a number, and as I hover over that column heading, you see that it shows the name and the fact that it's a number. If I right-click on that column heading, I have the ability to sort, normalize, or even remove the empty rows rather. And let me remove the empty rows first. And what we're going to do is now tell TrueFindings that, in fact, this is not just a number. It's not just any number. It's a weight, and it's a weight in pounds. We could have set our original spreadsheet up such that that would have been already identified here, but I wanted to show the process of doing that once you have the data imported. We can go to Normalize, right-clicking on that column heading and going to the Normalize option here. We can now identify it as not just a number, but it is in fact a weight, and we have the option of either pounds or kilograms. When we click OK, TrueFindings now understands that this column of data is not just a number, but it's a weight in pounds. And why is that important? Because through the normalization process within TrueFindings, if we needed to change that weight in pounds to kilograms, we can quickly and easily do this. Just by using the Normalize tab again, once we change the weight to kilograms, you'll notice these values in this column update to reflect that new normalized unit. All right, so let me undo what I just did there. Let me call this a number again. For weight, going between pounds and kilograms, not really a big deal for us, but cost is usually much more important and interesting for us to face as a normalization process, because we typically have many different currencies, possibly different currencies, many different base years, and how do we normalize between all of those quickly and easily? As I said before, we could do that when we set up our original spreadsheet by identifying different columns of cost data as different currencies or different base years. And when we import that into TrueFindings, it will normalize all of that to the currency and the base year that we dictate for us automatically. But let's take another. I don't actually have any cost data in this data set, but let me take one of these other columns and we'll pretend, we'll use our imagination that it's some type of cost. Let's say that it's a unit production cost or total production cost in thousands or millions of dollars. But let's identify this column here as some type of currency. And I'll right-click on the column, go to Normalize, and let's call this a currency. It's in a US dollar in a 2015 base year. And we'll click OK. And again, that just identifies what it currently is. But if we have the need, if we collect some source of data that's already in some base year, maybe a 2015 base year, as this example, and we need to normalize that to our program base year, maybe a 2011 or some other year. How can we do that quickly and easily? Well, we can simply right-click on that column, click Normalize, and updating the base year to 2011, once I hit OK, you will notice these values in this column adjust. If this was a column of cost data in 2015 dollars, it would now be represented as cost data in 2011 dollars. So TrueFindings is an excellent way for not only you to collect and analyze the data, but also very much helps in the normalization process, which we all know is critical. Before you begin the analysis, you have to make sure your data are normalized. So we'll switch towards the analysis options now available in TrueFindings. First, let's define what a finding is. A finding is a useful bit of information that we find in the data set, and it's what we're going to drive into our TruePlanning estimate in order to validate and defend those inputs. As you saw earlier, our scenario is that we have to develop an estimate for an aircraft engine, but we're not exactly sure where to start. The program may be just beginning, we have no schedule yet, no weight statements, no technical specs, maybe other than some overarching aircraft performance parameters. And what we're doing is we're hoping to use this data set and some of those performance parameters to get a better understanding of what our TruePlanning input should be. In our case, we're focused in on the weight of that engine. So we'll start with some very simple univariate analysis, and we'll look at the descriptive statistics of our column of data. And I'll begin by selecting any value. I'll just click anywhere in this weight column here. Now, as soon as I select on any column containing numbers, the analysis below is automatically updated. And this happens even when I jump back and forth between columns. We'll talk about all of the statistics available in the charting that we have, but take a look at what happens even when I quickly bounce back and forth between any of these columns that contain numerical data. It's rapidly updated both in terms of the descriptive statistics and the charting. So again, can we do this type of work in Excel? Sure. Can we do it as quickly and efficiently as we can in TrueFindings? No way, not a chance. What we're going to look at is we know that similar airframes as ours that we're concerned with have about between 5,000 and 9,000 pounds of dry thrust. So I want to make sure that I filter in our data set on those relevant data points. And again, this may be a historical accurate data set, but it's important for us to make sure that we're also looking at a relevant data set so that our analysis is accurate and relevant as well. So once we filter on that range, it leaves us with 43 data points, and we see that up at the top here. And let's talk about the lower half of this screen now. The default view in the Distribution Finder tab is a box and whiskers plot. And what I'm going to do is make this chart a bit bigger here so you can see it a little bit better. Any of these tabs here within TrueFindings can also be detached and pushed to a second monitor. So what I typically will do is push the charting to one monitor and make it nice and big and have the data set and other items on another monitor. The box in the box and whiskers plot that you see below represents the 25th through the 75th percentiles. And we can expand the whiskers, if you will, to encompass a larger or smaller percentage of that data. We can also look at the distribution in terms of a histogram and with a few typical curves laid on top of the data to get an idea of the underlying distribution of that data, as well as a cumulative distribution function, or what we typically call an S-curve. So my favorite out of all of these is the box plot, and learning very early on the importance of plotting the data. And this view quickly helps us detect subsets of data by seeing patterns or other groupings within our data. What we're going to do here is take a very simple approach just to show you how easy we can find and utilize useful bits of information from our data set, and we'll create our first finding, and we'll use a very simple example of us taking a simple average of all of these 43 engines that we see here. So if I wanted to take a simple average and I wanted to utilize this value in my TruePlanning estimate, I could certainly scratch it down on a piece of paper, type it into my TruePlanning estimate, and I'd be fine. But the benefit of using TrueFindings and creating a finding is it not only links this value to your estimate, it also links all of the charting, all of the data that you used in your analysis, and also all of the filtering. So it's definitely a better way to validate and defend your inputs and to drive your data into the estimate, because all of this information actually accompanies that input when we use it in TruePlanning. I'll talk a bit about the caution of using averages in just a second. But first, let's create our very first finding. And you can go to any numeric value in TrueFindings, whether it's an analogy in your own data set or whether it's a value from the statistical output, and we can simply right-click on that number. And you'll see an option here to create a data finding. And again, that finding is the useful bit of information that we want to utilize in our TruePlanning estimate. And I'm going to rename this. It'll give a default name, but I want to give it something that makes a bit more sense to me so I can easily pick it out. We'll call this average weight. And we're good estimators, so we'll make sure we add notes. And this is for those engines that have dry thrust between 5K and 9K. And we'll click OK. What that did was create a finding, as I mentioned, and all of your findings will show up here under the Findings tab. And again, this value is what's going to be used in our model if we choose this particular finding, but most importantly, accompanying this value, like I mentioned, actually attaching it to the TruePlanning project is going to be all of this analysis, the data, the charting, the statistical output, everything else will be accompanying with it. So my 2 cents on caution on using averages and the beauty of being able to quickly plot your data efficiently is, let me pull up an example here of when it would be a horrible idea to use an average, right? Here's a clear example where when we plot the data, and we could have 1,000, 2,000, 3,000 rows of data, but when we plot that, it's very apparent that we have subsets within our data set, and using an average here shoots us right down the middle of absolutely nothing. Our average is contained in neither one of these subsets, and our engine that we're concerned with at this point may be more like one of these subsets than the other. And it's important for us to now pause and do our homework and do that analysis to figure out how that data really are behaving behind the scenes. Maybe there are different subsets. Maybe we're looking at turbofans and turbojets together. Maybe we're looking at mixed commodities in our data set. But we wouldn't be able to see this as rapidly if we didn't plot the data. That's one of the beauties of TrueFindings and the speed at which it will plot the data for you. All right, so we did create a finding based on the average engine weight. And as I pointed out, anytime you want to see your findings that you've created, you can simply click on that tab. But we're going to move on to some a little bit more complex analysis. And first thing I want to do is let me remove these filters and start sort of from the full data set before we move over to the Dependency Finder tab. So on this tab, we've looked at the distribution of the data points and the descriptive statistics. This was univariate analysis. We're looking at one variable. In the other tabs, we will be looking at more than one variable at the same time. On the Dependency Finder tab, we're going to start to explore interdependencies among the variables. First, we would choose our variable of interest. In this case, it's still weight. And then we're going to select some other variables that make sense to us, first of all, and that may have some correlation with our variable that we're interested in. One thing we need to do is any of the columns of numbers that we're interested in analyzing, we need to make sure that we exclude those rows that don't have values in them. And I can quickly do that just by right-clicking on any of these column headings and select the non-empty rows. And I'm going to do that for dry thrust. I'll do that for wet thrust, and I will do that for weight. So what I'm able to do now is start to look at, I want to look at weight. I'm interested in weight. So I want to select weight, and then what happens below that is all of the other columns of variables that are able to be looked at in terms of correlation with weight now show up. And keep in mind what's happening over here on the right-hand side as I select the different variables. With each check of an additional variable, will automatically build out a scatterplot matrix as well as display the R value, the pairwise correlation between those two variables. So here I've added dry weight, dry thrust, and wet thrust. And immediately, graphically, you can see a very strong relationship between dry thrust and wet thrust, and that makes sense to us. But what we're most interested in right now is dry weight. And do we have some indication that there may be a relationship here between dry thrust and dry weight? And if I know the target thrust for my weapons platform, can I get an idea of what weight of an engine may be required to deliver that performance? So as I click on this relationship over in the right-hand side, the appropriate scatter plot will highlight as well. And simply by double-clicking on this scatter plot here, what we're going to do is automatically set up a series of regression equations for any potential relationship between thrust and weight. So when I double-click on this, what it's going to do is take me to the Curve Finder tab, and it's going to set up a series of regression equations across a number of trend lines, which we'll see right now. And once again, I'm going to steal some room over here so we can see everything that's happening. And what you see is, again, because we double-clicked on that scatter plot, it automatically sets up the bivariate regression for us. We have our independent variable here selected, dry thrust. We have our dependent variable selected, dry weight. And we can certainly come in here and set this up any way we want to by clicking on the different variables and setting that up anyway. I just wanted to point out that that will automatically be done for you if you double-click on those scatter plots. All right, so now what we're going to do is simply define our independent variable, our dry thrust. And in our case, we have some overarching performance parameter that's targeting our thrust for our aircraft at 5,250 pounds. And we'll hit enter, and keep in mind what's happening here as I do that, because what we have here is 5 models. You see the models here, and using these trend lines, we have the associated R-squared and standard error for each one of these. And as soon as I hit enter, TrueFindings will solve each of those models for us. And any of these trend lines that happen to be checked, and we can certainly select or deselect as many of them as we want to, whichever trend line is checked, you'll see the solved value down there, the star, as well as the trend line itself. Again, back to the importance of plotting the data. This was just a data set taken directly off the web, so not much more analysis has gone into it other than this demonstration. But some things jump out at me, and they may be jumping out at you too. You start to detect pockets, right, of information here. So we have probably 2 distinct pockets and possibly 3. And should I be using all of this data to develop this regression equation, or would it make more sense to filter down on a much smaller subset of that data, because we'd likely get a much different regression equation out of it. For this example, we won't chase that down, but it's an example of, or a demonstration rather, of how quickly and efficiently plotting the data through TrueFindings can point these things out to the analyst. And now you can get to that 80% solution much, much quicker, and you have much more time now to chase down all of the things that we need to be chasing down, but usually time is against us. Also, to solve or to use a value for the independent variable, we could type it in, but as I hover over this chart, you notice that red bar there. Wherever this bar is on the x-axis, if I click, it will use that value to solve all of these equations instantaneously. So as I click on different values, you'll see those values updated, those solved weights update. Let me solve for our original 5,250 pounds. And we'll take a simple approach again, and we'll say we really like this simple linear regression model. We have our R-squared and standard error, and we're going to create yet another finding. And this is a weight that we may use in our estimate instead of that 1,500 pounds that we saw earlier. So to create a finding, same process, right-click on that value, create a finding. Maybe I'll rename this simple linear regression thrust and weight. And again, we're good estimators, so we add notes to document who did it, the rationale, when they did it, and so forth. So we've created a couple of findings now. One through just taking a simple average. We looked at how to detect and calculate correlation among variables, and then we looked at developing bivariate regression across a number of trend lines here. And again, how to quickly plot not only the regression lines, but plotting the data to detect some potential areas of interest. So for our last example of data analysis, we're going to demonstrate how to quickly and easily develop a multivariate linear regression model and evaluate potential estimating relationships. We're going to take a little bit different path with this one. Let me clear all of my filters here and start from the full data set so I can walk through the entire process with you. But instead of trying to drive inputs for TruePlanning, whether it's weights or complexities or whatever the case may be, let's talk about using TrueFindings for other things. It's a very powerful, convenient stats package on its own. And let's talk about using the MultiCurve Finder to maybe see if we can't calculate a fuel consumption rate for our new aircraft engine based on some of the information that we may know now. All right, so I'm going to click on the MultiCurve Finder tab. And once again, we'll have our options to select our dependent and independent variables. But for this example, first we're going to filter out some empty cells. And we're going to take a look at dry thrust, dry fuel consumption. Let's take a look at the fan diameter as well. and the weight. So I've just filtered out all of the empty rows rather from each of those columns because now when I come down and start looking at the fuel consumption, when I'm trying to find a fuel consumption rate based on some other parameters, those columns will be available to me to use in the analysis. And it makes sense for a fuel consumption, how fast, if you will, does the engine have to go? How much does the engine weigh? How big is the engine? And these are all at least represented by proxy with these three variables here. So as I start checking, selecting or deselecting these independent variables, let me give us some more room here. As I start doing that, I want you to focus in on what's happening over on this right-hand side, because with selecting one independent variable, immediately what happens is we generate a linear model. We have a place for us to define that independent variable, and we also, to the right, have all of our statistical output for that model. And under the MultiCurve Finder tab, it's a much more robust output, if you will, than under the Curve Finder tab, even though this is only one independent variable and one dependent variable, right? So we have R-square, we have analysis of variance table, p-values, f-statistics, coefficients table down at the bottom, all the information that we should need to quickly and accurately validate the models that we're generating here. So that's just with one click. Let's start adding more variables, and I want you to keep an eye on what happens over here, how rapidly, with just a click, that this model, the model updates, the charting updates, as well as all the statistical output updates immediately upon checking the variables. So we'll add all three variables to the model, and as we start to select or down select many different variables, if we had them to choose from, we come up with a model that maybe starts to make sense to us. And what we're able to do is, again, solve for those independent variables. So for thrust, we had 5,250 pounds. For weight, we had 1,896 pounds. And for the fan diameter, we'll say that the fan diameter is 36 inches. And as I click enter, we now have solved the fuel consumption for an engine with that capability that weighs about that much and is about that big. And looking over at the statistics, even though we'll have a full week in sunny San Diego to debate over this very topic of statistical analysis, we do see a relatively respectful adjusted R-squared. Some of the statistics that I quickly key in on to validate a model, of course, for the model as a whole, we're hoping for a p-value typically below 0.05 with the corresponding high F statistic, and we have that here. Also looking at the statistical significance of each variable in our model, we see that each one of those appears to be statistically significant. So we could create as many findings as we like and explore many relationships, but looking at the clock here, I need to quickly move back over to TruePlanning and talk about the utility of creating findings and how we package those and drive those into our estimate. So I'll save what I'm doing here. I'll just save it to my desktop and close TrueFindings. And I'll get back into the TruePlanning estimate here. Let me close that for a second. Our original TruePlanning estimate, where we have our aircraft estimate, and we're looking at just the engine right now. And before, just like when we were in TrueFindings and we right-clicked on a number to create a finding, we do that same process in TruePlanning to link a finding. And again, we'll show the benefit of linking that finding versus just coming in here and typing in 1,896 pounds. I'll right-click on this weight here, and you'll see I have an option at the bottom to link this value in the input sheet to a finding. And we're going to pick the linear regression model that we developed that has a solved value of about 1,900 pounds, and we'll link that to the estimate. And what you'll notice now is you have a little icon to the right of that value that notes that it is, in fact, a finding that has been linked there. The benefit here is as you save this project, as you forward this project on for the typical review process, you're very likely going to get challenged on your assumptions and where did you come up with this weight? How are you defining this weight as 1,896 pounds? With a click on that finding, and this is packaged along with the TruePlanning estimate at this point, what will happen is it will bring up the exact spot you were in TrueFindings when you created that bit of information. We have the data set that we used, we have the filters that we have employed, all of the charting, all of the trend lines, and the particular value that we selected to justify and validate that input. So this is a beautiful way throughout the estimating process not to just only analyze and normalize your data, but to manage your data and to make that data effective by driving it into TruePlanning or any other model for that matter, due to the relationships that you're able to quickly and accurately find in the TrueFindings application. So looking at the clock here, I think this is going to conclude our live demo of TrueFindings. I'd like to make sure I, of course, save enough time for questions and answers, and I'll turn it back over to our moderator. But again, thanks for attending. Please don't hesitate to reach out to Price Systems or to me directly if you have any questions about what I covered today. And I hope to see you all in San Diego at the ICA Conference in just a couple of weeks.
Thanks, Joe. So we got a couple of questions. The first one is pretty straightforward, so I'm just going to read it. The question is, what is the method used for inflating or deflating the dollars? Is it DoD inflation indices, Air Force, Army, or some other appropriation specific?
Some other is the quick answer. It will rely on the default escalation tables that we currently use in TruePlanning. And if you've used TruePlanning before, you'll know that the default escalation table for the United States, for example, is based on the CPI.
Okay. And then I am going to unmute Quentin. Quentin, can you hear me?
Yes, I can.
You had a bunch of questions, so I think I'm just going to let you go for it.
Quentin Redmond is not allowed to ask questions.
Oh.
Uh-oh.
Joe, I had a question on the distribution finder.
Sure.
On how would you determine the best fit values regarding if you had a new developed engine and that may or may not have testing values? In other words, there may be some basis for the outline anomalies that you have. In other words, how do you assign the risk in here is what I was asking.
That's a great question, and boy, if it's ever true that cost estimating is an art and a science, that really brings in the art side of it, right? Because just because something shows up as an outlier, if you will, on that distribution finder, the one thing that really bugs me is when people tend to get rid of outliers, and I often say, why? And the answer is because it's an outlier. And it makes me bristle because that outlier could be exactly like the item that you're trying to estimate. So it really gets into the art side of it, and the duty of the estimator to have to chase down every single one of those outliers and determine why is it in there. Can it really be excluded because it's in fact not an aircraft engine but a tank engine? Mm-hmm. Or is this engine using something that's state-of-the-art, advanced concepts and things like that. And it may have no bearing of what I'm estimating, or it may be exactly like, and I end up using that as a direct analogy. So long story short, I feel that gets into the art side of it, and it gets into the duty of the analyst, of the estimator, to chase down and not just look at the numbers, look at the why those numbers are showing up the way they're showing up.
Okay. And I guess the other one I had was in regards to TrueFinding extensive databases for complex, like missile systems, radars, space vehicles, and associated software for these products. I assume that's in the database. Is that correct?
Well, TrueFindings is the application that allows the estimator to bring in their database. I believe we are looking at some, along with any database, you have to make sure the proprietary information and so forth is masked. I believe we are looking into that if we have some cleansed data that can be made publicly available. But the example that you saw today was, you know, if I have the U.S. missile data book, I could easily convert that into Excel and push that in there. Most of the data that we'll find in a program office, they're not going to want to release that in terms of any publicly available data sets. TrueFindings is the way for the estimator to make use of the data that they already have first and foremost.
Okay. So that would be the same thing for like systems of systems and any engineering or manufacturing associated logistics for any kind of product, is what you're saying. Okay.
Absolutely.
Okay.
Yeah, the statistical power and the speed and efficiency of plotting your data should definitely not have you focus on only driving inputs into TruePlanning, but on its own, and I've used it very often on its own as just a powerful stats package to do whatever I need to do for any estimate.
Okay. That was it.
Thanks, Gwen.
Thank you.
Okay. I just got one more question. What is the size of the application as far as memory is concerned, and what requirements are there for running it, and how often are there updates to the software?
The size is a good question, and I'm going to have to get back to whoever asked that. I'll take a name in it. In terms of the requirements for running it, this is a licensed product, and it works very well with TruePlanning, and it can be licensed separately on its own or in conjunction with TruePlanning. So I would encourage the audience member to contact their strategic account manager at Price Systems, or call 1-800-43-PRICE to discuss the price of a license for TrueFindings. Typically, updates to our applications are done, major updates are done, they have been done recently in about a 2-year cycle, but one of the TrueFindings is relatively new application, and along with TrueMapper and some of our other applications, in my opinion, and hopefully I'm not speaking out of turn, these are new enough to where we develop these applications with trying to figure out every scenario possible that the user will encounter. Invariably, there are scenarios that we didn't think of, and customers have come back to us and say, gosh, it would be really great if TrueFindings did this. And because of the way that we respond to the customer like we do, you'll often find those great suggestions incorporated in much sooner updates, especially for applications like TrueFindings and TrueMapper that are relatively new.
Okay, and then we just got another one. They're all coming in, so folks, don't be shy. We'll still take them. This is from Jeffrey Hammond, and the last one was Mark Webster. I'll send you Mark's contact info.
Okay, great.
How can different locations share TrueFinding databases and/or specific CERs?
So very, very easily, I guess first the question of sharing TrueFindings databases. Remember that the genesis of all this is a simple Excel sheet. So it could be just as simple as emailing or posting to a shared drive the originating Excel sheet that can be then quickly imported. Also, if you notice when I saved my work in TrueFindings, it saved it as a unique TrueFindings file. It's a TrueFindings knowledge base file, I believe is the extension. But that can just as well be shared among users. And if two users sitting side by side have TrueFindings, one can share their findings that were saved with all of the CERs, all of the underlying data, simply emailing that as an attachment or sharing it on SharePoint. The other user simply goes to File, Open in TrueFindings, and all of that information will be there for them.
Okay, then I'm just going to pause for a minute to do last call. All right, sounds like we're good. You guys can always either email me at megan@icaonline.org or joe@joe.bauer2@pricesystems.com if you come up with a question after we close today. But thanks to everyone for joining us. We here at ICA think these are really great opportunities for everyone to get to know what's going on in the cost estimating world, and we hope you tune in to our next one. Thanks again to Joe Bauer and Price for coming out today. And do you have any closing words?
No, just a shameless plug for the again the ICA Conference, and Price Systems will be hosting many great training sessions as well as papers, and a shameless plug for myself. We're having a presentation on Thursday, I believe, for the cost estimating challenges of additive manufacturing. Very important topic that's just gaining more and more speed, so I hope to have you all out for that presentation on Thursday of the ICA Conference.
Awesome. I like it. The plug, no shame here in that plug. So, all right. Well, thanks everyone. We're going to close out and have a good afternoon.
Take care.